Hi everyone, and welcome to the first lab of the semester, which is entitled Microscopic Examination of Stained Cell Preparations. This lab is designed to introduce you to the proper operation of a microscope, the parts of a microscope, and some common errors and mistakes that are made when using a microscope and how to avoid them. When you retrieve your microscope, you should always carry it with one hand holding the arm and the other hand underneath the base. This is the safest way to avoid dropping the microscope. Your microscope will be covered with a protective sheath, which should be removed before use. And then you should plug the scope in by unwrapping the extension cord from the back of the scope and placing it in an outlet. On the back or side of your microscope, there will be a power switch. When you turn that power switch on, you will be able to see that the light source, or the substage light, is activated. On one side of your microscope, there will be a light control knob. When you rotate that light control knob, you will see the light increase in intensity or decrease in intensity, and this is one way that you can control the amount of light that reaches your eyes. What we're working with today is called a compound light microscope. It's called a compound light microscope because it uses light as well as a compound or dual set of lenses to magnify an object greater than what you can see with your naked eye. So there are two lenses in this microscope. The first lens is called the ocular lens, and the ocular lens is the one that you would put your eyes near when looking through the microscope. This lens has a 10x magnification, meaning that it magnifies objects 10 times greater than what you can see with your naked eye. The other lenses are called objective lenses, and there are 4 different objective lenses on this microscope that have varying magnifications. The objective lenses are attached to a revolving nose piece so that they can be switched out for different degrees of power. So in this compound light microscope, light will travel from the light source up to your specimen. It will enter the objective lens and then pass through what is called the body tube up to the ocular lens and then create a picture for your eyes. Let's take a look at the different magnifying powers offered by the objective lenses on this microscope. The first objective lens, as you can see, has a red band and is called the scanning lens. This one has a 4x magnification power. The next one has a yellow band and is called the low power lens. This one has a 10x magnification. Next, we have a lens with a blue band. This one is called the high power lens, and it has a 40x magnification. Lastly, there is the 100x oil immersion lens with the white band. The total magnification that reaches your eyes in a compound light microscope is equivalent to the product of the ocular lens and the objective lens. As we saw, the ocular lens is 10x, and it always will be because there's only one set of ocular lenses on this microscope. So to calculate the total magnification on this microscope, you merely need to multiply the objective lens's magnification by the ocular lens, which is always 10. For example, if we have the objective lens set to the 4x scanning lens, then the total magnification will be 4 times 10, or in other words, 40x. When you are getting a specimen in focus, you always want to start with the lowest power objective lens available to you on the microscope, which in this case is the 4x scanning lens. Let's take a look at how you set up a specimen for examination on the microscope. Your specimen, which will be placed on a slide, will be arranged on this black platform here called the stage. On the left side, you can see that there is a metallic implement, which is called the stage clip, and you will place your slide flat on the black platform, open the stage clip, and make sure that the slide is arranged in this 90-degree corner over here before allowing the stage clip to hold it in place. This will ensure that the slide remains in a fixed location, but a location that you can control using a set of knobs called the mechanical stage control knobs, which are hanging down from the right side of the microscope. As you can see, as we rotate the top knob, the specimen will either move toward you or away from you, and if we rotate the lower knob, it will move left or right. This is important because it allows you to move your specimen around on the stage to get the optimal view, and it also allows you to ensure that your specimen is centered over the light source. One common error that students may make is that they start out without their specimen being properly centered over the light source. The microbes that you look at are tiny, and they may only occupy one small fraction of the surface area of the slide. You want to make sure that this particular area is centered over the light source, otherwise you won't be able to see anything no matter how hard you try. So you can use the mechanical stage control knobs to get started off on the right foot and make sure that you are looking in the area of the slide that you need to look. Underneath the stage, there are two other components of the microscope that we need to talk about, and those are the condenser and the diaphragm. The condenser is a special lens that doesn't offer magnification, but rather it takes the beam of light coming up from the light source and condenses it into a concentrated pinpoint which will hit your specimen as it passes through the stage. The diaphragm is sort of like a camera shutter lens, which can be opened and closed to control the amount of light that is passing through the condenser and up to your specimen. The diaphragm control lever allows you to either open or close this shutter and control the amount of light that you're getting. As you can see, as we move the diaphragm control lever to the left, we increase the amount of light that reaches the specimen, and if we move it to the right, then we close the shutter and we decrease the amount of light that reaches the specimen. So the diaphragm is an important component of the microscope to adjust as you move up in magnification. And the reason why is because, as you can see, these objective lenses get longer as you move to the higher magnifications. The 4x is the shortest lens, 10x is a little bit bigger, 40x is bigger than that, and 100x is the biggest. And as you move higher in magnification, the length of the objective gets longer, which also means that less light ends up entering that objective lens because of the proximity of the lens to the slide. So as you go up in the magnifications, you want to increase the openness of the diaphragm so that more light can be captured by that higher power objective with its longer length. Now let's talk about how we focus the microscope. The microscope is focused using coarse adjustment and fine adjustment knobs, which can be found on either side of the body. As you can see, the coarse adjustment knob is larger and the fine adjustment knob is smaller and located on top of the coarse adjustment knob. As we rotate the coarse adjustment knob, we can see that it actually changes the height of the stage, bringing it closer to the objective lenses. Therefore, it is important that you pay close attention to the height of the stage while using the coarse adjustment knob, and never adjust the coarse when you are using the high power 40x or oil immersion 100x lenses, because you could crash the lens into your slide and damage the slide, or even worse, damage the lens. When getting a specimen in focus, start with the lowest power objective and start with the stage all the way lowered. Raise the stage slowly until you are able to see your specimen. You want to do this slowly because the specimen may pop in and out of focus very quickly, so quick that you might miss it if you're going too fast. When you see your specimen, it may not be completely in focus, but that's okay because then you can use the fine adjustment knob to bring it into sharper focus. Once your specimen is in focus at 4x, don't touch anything. Don't change any of the settings that you've adjusted on the microscope. Don't touch the coarse, don't touch the fine, don't touch the mechanical stage control knobs. All you want to do is rotate the next highest power objective lens, which in this case is the 10x lens, into position without altering anything. These microscopes are designed so that your specimen should be either in focus or very close to being in focus, as long as you don't adjust anything that you've done so far. You may need to make small adjustments to the fine focus when moving up in magnification. Once your specimen is in focus at 10x, you can switch to 40x. Again, you may need to make small adjustments with the fine focus knob. What happens if you do bump something and lose sight of your specimen while switching in between the different objective lenses? This means that you will need to go back down to the lower magnification and try again. It is very unlikely that you will be able to recover your specimen at a higher magnification, and it can even be dangerous because you may risk bumping the stage into the objective lens. So if you lose your specimen, drop down in magnification and try again. Before switching to 100x, there is an extra step that needs to take place. A substance called immersion oil needs to be added to the surface of your slide. Why is this necessary? As you can see, the 100x lens is the longest lens, and this creates problems because of the proximity of the lens to the slide, which allows a lot of light to escape. This is due to a property called the refractive index of substances, which describes how much light bends when it passes through one substance and into another. As light passes through the glass of the microscope slide and out into the air, it bends, and the closer that objective lens is to the slide, the less of the bent light beams are going to be captured by the objective lens. To fix this, oil is added to the slide because the refractive index of oil is more similar to the refractive index of glass, meaning that light will bend less when it passes from glass to oil compared to when it passes from glass to air. This allows more of the light to be captured by the 100x objective instead of the picture you get just being completely dark. Thus, you want to add a drop of oil that will seal the interface between the slide and the objective. You want the oil to touch the surface of the lens, and this is the only lens where you want this to happen. Oil should never come into contact with the lower power objective lenses such as the 4, the 10, and the 40 because it can damage them. Only the 100x oil immersion lens should be used this way. To apply the oil, you want to rotate the objectives into no man's land, which is the area that I call the region between the two objectives, and then place a drop of oil on the center of your area of interest. Then slide the 100x into place. Even with the help of the oil, you will probably still need to open your diaphragm a little in order to allow more light in to get a clear picture. Once you have finished examining your specimen at this highest 100x magnification, you will need to clean the oil off both the slide that you are using and the microscope. To do this, you want to use lens cleaner and lens paper, which is specially designed not to damage the lens. If oil has gotten on any other part of the microscope, such as the stage, then you want to clean that off too. When you put your microscope away, lower the stage as far down as it can go, return the 4x objective into position, turn off the light source, wrap the cord properly, and replace the protective sheath.